So a question like this is very simple, but it requires you to understand it to the fullest. Okay, so the question reads, of course this is free fall motion, and we have a question which reads, a hot air balloon is rising vertically upwards with a constant velocity of 5 meters per second. A sandbag is dropped from the balloon and hits the ground 4 seconds later. What will it be the velocity of the sandbag when it strikes the ground? We're talking about the final velocity. What height of the sandbag? Because this has to be sandbag. Yeah. So questions of this type, if a balloon is moving upwards to a certain height, then when it happens to drop an object, what you notice is that object won't just go downwards if it has been dropped whereby a balloon is moving upwards. If that same balloon happens to drop an object after a certain height, what you notice is that object is going to take a path that will be like, it will move a bit up, then it will drop. If it drops the sandbag at this given position, the sandbag won't just go direct downwards, no. A sandbag will take this route. It will move a bit up, then it will drop. That's the concept which is there based on this same question. So according to free fall motion, we said if an object has been dropped from a certain height, h, whereby the initial velocity here is given as 5 meters per second, that object, of course, when it moves up to the maximum point there, it will have the final velocity here as 0. Then when it is moving up to downward somewhere there, you notice that it will have its own high final velocity. So they're saying it takes 4 seconds for it to move from the point of being thrown to the ground. I'm saying if a balloon is moving upwards, it happens to drop an object. That object won't be dropped downwards direct. It will a bit move up, then that's when it is going to drop. Why? Because the balloon will keep on moving upwards without stopping. But a sandbag itself is the one which is going to move up a bit, then it will drop, taking that same route. So these people are trying to ask us to calculate for the final velocity. How are you going to get the same final velocity? Final velocity, it can be calculated in so many ways. But in this case, the best is, let's try to calculate the same final velocity using the formula V is equal to V initial plus acceleration multiplied by the total time. So since this is free fall motion, definition for free motion, we are saying it has to be a type of motion where gravitational acceleration is the only type of force which is acting on the object. Meaning that this guy has to be gravitational acceleration. When velocity is constant, acceleration is equal to 0. So you can't use this guy in this instant. Due to the fact that we are dealing with free fall motion, we have to take this one to be gravitational acceleration. And if you check, the object has been projected upwards initially. We expect acceleration here to be negative g, meaning that final velocity will be calculated as v initial minus g multiplied by the time t. When you happen to get the time t, of course, all what you need to do in this case has to be, we know what the initial velocity is, we know what g is, and also the total time that we have. Total time is 4 seconds, g has to be 9.8, the initial velocity is taken to be 5. So just plug in the same numbers here. V has to be equal to 5 minus 9.8 multiplied by 4. So the final velocity in this case has to be equal to, someone try to help me with rate of punching. Just write 5 minus 9.8 open bracket 4. Then you say close. It will give you the final answer in this case. Negative
34.2.
Alright, that is all how you get the so-called final velocity. of course, velocity can be negative depending on the issue of it moving downwards. If you happen to reach at this given position, you find that velocity that will be here, it has to be the same as the velocity you take to move up, it will be the same as you're going to take to moving somewhere there. So since we are now pointing downwards, this of course will be negative, like the way it is. Height, we said, if you have a height which is in this way, and if a particle happens to move up, then it goes beyond the point of projection, or the point it was thrown from. This guy has to be what? Negative. We said this has to be negative h, which is equal to the initial velocity multiplied by the total time, then I'll say plus 1/2 acceleration multiplied by t. So this is free form motion. We expect that guy to be a g. And since the object has been projected upwards initially, that guy will be negative as well. So we have negative h equal to, and here we have the initial velocity multiplied by time minus 1/2 g t squared. We have all these parameters on the right hand side, initial velocity, time, as well as a g, meaning that you have h equal to initial velocity 5, time it has to be 4, minus 1/2, g has to be 9.8, time has to be 4 squared. Negative h has to be equal to 20 minus 4.9 open 16. Would you try to punch this on a calculator as well, so that you can be able to get your final answer? What answer are you getting? 20 minus 4.9 open bracket 16 plus
Negative 58 to 15.
negative 58.4. So since we have a negative and negative, these two will go. Then sandbag will cover a height of 58.4 meters. Sandbag will cover a height of 8. That's how you answer for the final velocity. It will take somewhere there, even the height itself. Remember to put this guy to be negative because it will now be moving beyond the point of projection. So height has to be negative. If it happens to move up, then it goes beyond. If it was to be direct, we'll have to take this guy to be like the way it is. Thank you. That's how we answer.